Hello, today I'm going to present the project's progress report for the inverted pendulum control system. So, what is an inverted pendulum? Inverted pendulum is a classical, famous, unstable system that used a lot in the automatic control system study. Why? Because the significance of studying how to balance an inverted pendulum can offer great insight on how to balance much more complex systems such as rocket control. Because interestingly, the inverted pendulums could be viewed as an simplified version of the rocket in the air. So studying that can help the aerospace engineer to know how they can balance a rocket launch. So this is the schematic of the system itself, um, and this is the modeling of the physical system. For this project, I have added the friction in the modeling process, which is the tiny f right here, and so for the balancing, the cargo underneath will move left and right and in order to balance the inverted pendulum in the upright position. So the modeling plan is first implementing the inverted pendulum without the control force. Second, and then evaluate how dynamic behavior of the model. Then we implementing the control algorithm, and then we evaluate the result and see if it meets the expectation. Also, the project will use Python and some mod plotting library for implementation of the simulations. So assumption we're gonna make. So as you can see from the schematic, the assumption we make is that we have evenly distributed mass, meaning the mass center and the center of the gravity will always be the geometric center of the object. And also the pendulum rod is massless in our case. Also the friction force is constant under different rotation angle or the rotation speed. All those assumption is just try to make the system a little bit more simplified. The variable, this is the list of the variable we are trying to we are modeling, which also shows in this. You can match them in the schematic diagram. And then verification of the result, you can see that which without the control force, which expected the angle converge back down to the downright position. With the control force, you should always maintain to the upright position. And the problem we're facing is usually the time step we use in the modeling because this is such an extremely unstable system. So we should carefully choose the time step in the modeling. Thank you.